Hello, welcome to the Engineering Circuit Analysis Tutor. In this lesson, we're going to continue with the same circuit that we've used in the last couple of problems, at least the same component values, but we're changing it up a little bit in that now we have a 1.5 volt source going into the inverting input, but we've replaced this source with some labeled source. We call it V sub B. And what we're really trying to do is analyze this circuit and figure out what range of VB avoids saturation. All right, so that's kind of the key takeaway here. It's a very common problem that you'll have in amplifiers. In fact, it's very practical. What you need to do a lot of times is you'll have the circuit constrained, but you'll need to figure out how much you can drive the input to avoid this output saturating. Now, what do we mean by saturation? We've talked about this before. Basically, what we have for this particular amplifier is plus and minus 10 volts on the supply voltages. That means that if the output ever gets up to positive 10 volts or in the negative direction to negative 10 volts, then no matter how much you drive either of these inputs beyond that point, the output is never going to get bigger than plus 10 or minus 10 in the negative direction. So what we really want to do is write a set of equations to figure out how much we can drive V sub B in order to keep the output less than 10 volts or minus 10 volts. So our essential strategy here is going to be basically what we've done before, is to know the main ideas of an ideal op-amp. By the way, we're assuming this is ideal. That is that these two voltages are the same, whatever they are, due to the virtual short condition, and also that there's no current going into this op-amp at all, zero, because of the infinite input resistance. So our basic strategy is going to be to figure out an equation that's going to relate the output voltage in terms of the input voltage V sub B. We're not going to be able to do that in one step, but we want to write V out in terms of VB. Then we know the output cannot be bigger than plus 10 or minus 10, and then we'll just stick those numbers in and we'll solve for the corresponding values of VB that you're allowed to have to keep the thing from driving past 10 volts. So that's what we're going to do right now. We're going to write those equations and solve them and find the range of V sub B. All right, now the first step, as we talked before, is we know that this input signal to the non-inverting terminal is V sub B, whatever it is. And because of the virtual short condition, we know, without even doing any calculations, that this voltage right here at this node, which is the input to this inverting terminal, is also VB. So what I like to do is go up there and just kind of write that there to remind me that I know what this voltage is, V sub B, and that's a voltage with respect to ground because this is a voltage with respect to ground or the common reference node there. So this is V sub B. Now when you're trying to tackle a problem like this, you know that you want to find the output voltage in terms of this input voltage, but you can't do all of that in one step. What you really need to do is write down what you know to be true, and then you kind of inch your way over to figuring, you know, what the end game is, but you inch your way that direction instead of trying to write down what that is. So I look at this problem and I see that I have one